Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the difference between atomic number and mass number. Typically you will see the element over here, whatever the element is, the mass number will be up top and the atomic number will be on the bottom. What is the atomic number? Well, the atomic number is going to be the number of protons found in an atom. And because all the atoms of the same element have the same number of protons, we use it to identify the elements. The number of protons is used to identify. And if you look at your periodic table, let's see if we can pull one of those suckers up. Let's see the table. All these numbers you see up here are the atomic number or the number of protons. And you can see that that's how the whole thing is pretty much structured. Okay? So if it's not an ion indicated by a plus or a minus sign, the atomic number can also tell you the number of electrons that are present. Okay. Now, if it's a cation, for instance, what happens when we form a cation? Well, we've lost an electron. And because it's due to a loss of an electron, then we have to subtract from this atomic number to get the number of total electrons. So let's say it's let's get our periodic table over here. And let's look at carbon. Carbon has an atomic number of 6. So as long as it's not an ion of carbon, then we have 6 protons and 6 electrons. Okay. Had it been a plus sign there, that means we have 6 protons and we lost 1 electron to get this plus sign, so it would be 5 electrons. Had it been a minus sign there, it would be 6 protons and we gained an electron, so it would be 7 electrons. Okay? So that's what the next part of this is leading to. So if it's an anion, like this example up here, what you do is you take the number that's after the minus sign, and if there's no number there, it's implied to be a 1. Okay, it could have been easily a -2. Then you would add whatever that is to your atomic number. Okay, because we're gaining electrons when we form an anion. All right. And then finally, the mass number. Well, what is the mass number used for? Well, the mass number by definition is the number of protons plus the number of neutrons. Don't confuse this with the atomic mass. That has to do with the isotope abundance, and I'll talk about that in a different video. Okay, it's often confused. The only element that has the same atomic number and mass number is carbon-12. Okay, they both have 6 and 6, as well as the sum is. Hello and welcome to another one at D's ADD videos. Today we're going to be looking at atomic number and mass number examples. So usually we have an element, in this case the element is X, and then we have the mass number up top. If you remember, the mass number is going to be your number of protons plus your number of neutrons, and then we have the atomic number on the bottom. Okay, so in this case we can see that the mass number is going to be 25 and the atomic number is going to be 10. So right away all of these guys have 10 protons, 10 protons, 10 protons. The number of electrons is going to differ a little bit because there are a couple ions, and ions are formed by gaining and losing electrons. So therefore in this case there is no plus or minus charge, so no ion. So what do? Well, you just take your atomic number to be the same as your number of electrons. But here we have a +2. What does that +2 mean? It means we lost 2 electrons. So what do? You take your atomic number and you account for the loss of the 2 electrons by subtracting 2, and then you get 8 electrons there. Then here we have an anion in which we have a gain of 1 electron. So what do? We add 1 electron. We get a total of 11 electrons. These are the electrons. And then these guys were the protons. And then if you remember to get your mass number, what you do is you take the number, to get your neutrons, you get your mass number minus your atomic number. So let's do that real quick. Running out of space, I forgot to zoom in. So let's go ahead and do that here. So the neutrons, kind of sloppy there, but you know what I'm writing, is going to be the mass minus the atomic. So in this case, first one's going to be 15 neutrons. Here, we're going to have 15 neutrons. Here we go, 15 neutrons. Okay. That was a pretty straightforward beginner example. They can get more complex than this. So I just wanted to illustrate the basic concept before I did some more intermediate problems and advanced problems. All right. They might give you some problems in which you're given the number of neutrons and protons, and then you need to find the mass number or electrons and the charge or something like that. So make sure you watch the intermediate video for the more complex examples. I hope I've clarified any confusion you might have, and as always, practice, practice, practice. Thank you, and have a